are going over the nervous system some more. And so like I really wanted to expand a little bit on the idea of the excitatory postsynaptic potential and the inhibitory postsynaptic potential because they are really important. But it seems to kind of just be one of those little concepts that you're so busy trying to get your head around the action potential as a concept that you miss these like kind of two key components. And I want to just, like help with that. Okay, so we're going to go through those. So, let's just start with like what they look like. So we've already talked about, when we're on some of my previous videos, when you're talking about, like an action potential, for example, like here's a stimulus, right? It's giving, like, this is the voltmeter example that we looked at. And so an action potential is a way of like kind of measuring that, like being more quantitative about it, in terms of like the graph. But the other thing that we kind of can pull up and visualize on this graph is these little like teeny tiny, we started noticing, oh, there's like a little weird little, I don't went that way. What is that? Right? And they never really just reach threshold. And if you remember what threshold is, it's like, this definition where we have to reach this like negative 55 millivolts, and then if you can just get there, then all of a sudden, boom, you can get all the way up to the 30 positive and get your action potential and all that. Okay, so like the idea was like, what were these? And so what we found were that these were, oh, hold on, that was supposed to be eraser. So what's going on with this is these are excitatory, inhibitory, postsynaptic potentials. And generally what this means is we talked earlier about how neurons don't usually like exist all alone, right? So if you're a neuron, okay, and let's just say here's your petri dish or here's your part of the brain, okay, and here's like, here's a neuron and here's a neuron, there's a neuron, right? And they're all over the place. And they're all like connected, right, in different ways. And they're like making these networks, right? And let's just say that like this neuron over here, right, this neuron wants to talk to, say, this neuron over here, right? It needs to tell it something, like have a thought, like remember something, or it needs to say move your arm, it's falling asleep, like whatever it is. It has to actually kind of go through like a big network. Okay, so if you trace it out, this one is going to stimulate here, which is going to stimulate here. And what we, want to do is kind of just like maximize this route. Like this is the route that we want to take. But what happens is some of these other neurons, like they're still, in the general vicinity. Like some of them are excited here, right? And we want to make sure that they're not, going through this other outside route, right? That maybe this is a different memory. Maybe this is move your kneecap, right? Something else. And so we have to kind of, since they're so close together, we have to kind of ask them to kind of turn down their sensitivity, where we have to have these ones over here like work on turning up their sensitivity so that we can get that desired track between these neurons here. And so what we ended up doing is kind of like asking them in different areas to do different things. So an excitatory postsynaptic potential is telling these neurons like, hey, this is the route, we're going to get something, let's go. And so you'd have to stack them to be kind of doubly sure that this is really the signal, right? That we want to send the signal. Okay. So that would be, an example of what we'd want to have happen, say, over here, right? But then there's this other area, right, that we were talking about, like this zone, right? This little group here, which is related. It's physically closer, but it's the wrong idea. Like we don't. So what we do is we kind of ask them to turn down their volume. And we do that by using these inhibitory postsynaptic potentials. And what it means is we get ultra low, right? Like, so we're no longer at like our resting 70 millivolts, which is right up here, right? We actually are lower, right? We're slightly hyperpolarizing, if you will, okay? And it makes it harder for these other neurons to fire over here. It kind of turns them on, off, turns them like down, actually, more so. Okay. So I hope that kind of makes sense. And so, right. So if you have any questions, please feel free to email me, visit me during office hours and all that good stuff. I always love having visitors. And, all right. Well, I hope that was helpful, and I hope you all have a lovely day.